Okay, continuing with chi-square tests now. Now, before I start, pay attention to some of these past paper questions, the way they ask chi-square test. This is 2010, 10 years ago. They have a different syllabus, or slightly. So the way they ask these, would they expect you to look up the critical value from a table? For example, here it says, write down the critical value for this test. Again, write down the critical value for this test. And these are all before 2014. If you, when you're practicing past paper questions and you encounter these, it's not that you can't answer it because you were not taught to do this part. What you do is actually really go to the marking scheme. Write down the answer for this and continue on with the next part, making conclusion. The new way that they ask is they will always give you the critical value within the question, and then asking you to compare. So I don't have an example here, but when you practice more recent past paper questions on chi-square test, you will see that that's true. So now we have question 10. So we need to carry out a chi-square test to determine whether or not a person's choice of one of the three professions, engineering, medicine, and law, is influenced by the person's gender. State the null hypothesis. State 1 mark. Puppy, write down the number of degrees of freedom, 1 mark. Of the 400, and then he says, calculate the expected number. This part could prove to be tricky because you're so used to just use the calculator to read it out. And then say, here using the p-value to evaluate whether or not, to make a conclusion. Part A, state the null hypothesis. The null hypothesis must be the one that says independent. Please just stick with the word independent and don't fancy it up. Just copy what you can. So you say, that the profession, the three profession is independent of the person's gender. So that's all you need to say. The three profession choices is independent of the gender. Keyword, make sure you use it. Make sure you use independent. And then if you need to state H1, you say, instead of saying independent, you can say not independent. Just like not. Again, don't fancy it up. Right. That's A done. B, write down the degrees of freedom. Ooh. How do we know the degrees of freedom if we don't even see the table? Can we create the table ourselves? Or does it need to? So you have two categories. You have the profession and you have gender. So profession, you have 3. And then gender, you have 2. So if you have to have a table, then you will have engineering, medicine, and law. Then you will have female and male here. Degrees of freedom is the number of column minus 1 times the number of rows minus 1. So 2 minus 1 is 1, because you have 2 columns. Number of rows is 3, so 3 minus 1 is 2. So the degrees of freedom is 2. Of the 400 people Tony interviewed, 220 were male and 180 were female. 80 of the people had chosen engineering as a profession. So now calculate the expected number of female engineers. Part C. Well, since we already have the table, then we can just fill it out. So total number of female is 180. Total number of male is 220. Then the total number of engineer is 80. So what we have to do is to do one way of calculating this, the expected number, is you do a row total times column total divided by the grand total. So for the female engineers, the row total is 80 times the total number of female divided by total number of people in the interview. So you do 80 times 180 divided by 6. So you expect to have 36 female engineers. Tony used the 5% level of significance for his test and obtained a p-value of that. State his conclusion. So the p-value that you use to compare is at 5%, meaning it's 0.05. And since 0.0634 is greater than 0.005, then you need to make a conclusion. Do we accept or reject? But first of all, do you recall what a p-value means? Some of you are quite used to just doing the critical value and forgetting about the p-value. So the p-value is that the chi-square test, or the chi-square distribution looks something like this, with a very long tail. And anything that falls into this rejection region, then we need to reject H naught. So the confidence level of confidence says this tiny bit here has an area of 0.05, just like when you were doing a normal distribution, the area under the curve means the probability. So over here, this is your 0.05. The calculation of this says that we're here, 0.0634. So the probability is bigger than 0.05, not lower. So in that case, we have to accept H naught. So because 0.0634 is greater than 0.05, we accept H naught. That's all you need to answer. You don't need to even draw this diagram. This diagram is for me to help you understand what p-value is. Now, two more These two, I just keep it there to show you, for you to pay attention to these two. Okay, and if you are stuck at finding out what it is, the chi-square critical for this are 9.488. So then you can keep on calculating. Do one more example. This time is with a table. Questionnaire. So we have a category of different beverages or drinks for breakfast, and then age group. A chi-square test was conducted to decide whether the type of drink was independent of age. So you don't even need to, you do, write down. So let me highlight these. So find the number of degrees of freedom, 2 marks. So you better show a step of working. Write down the null hypothesis, 1 mark. Write down the critical value. So we need to look it up. Chi-square test statistics is calculated to be this. The p-value is this. Write down the conclusion. So they give you both to let you compare. Part A, find the number of degrees of freedom. We have number of columns. C is equal to 4, row is equal to 3. So we can do 4 minus 1 times 3 minus 1 to get 3 times 2, 6. B, write down the null hypothesis. The type of drink is independent of age. So I'm just going to highlight that out. And then you can just change it to is independent of age. And that would be your H naught. Part C, write down the critical value. Now this, with the degrees of freedom being 6 and the significance level being 5%, usually we go to the table. Well, for me. But now I'm going to look it up from the marking scheme. Right, I found it. The chi-square critical is equal to 12.6. So now we can use the calculated one to compare. They give you both. They give you the calculated one and then the p-value so that you have a way of comparing just one pair. Since I've talked about p-value already, I'm going to use the chi-square calculated. The chi-square calculated says, here, the same idea. This mark is 12.6. Anything that is exceeding this. So this is the critical value. Anything that is larger than this, again, falls into the rejection region. Now, this is all 146, which is way, way over here. Of course, then we must reject. So therefore, you can say 146 is greater than 12.6. Therefore, since 146 is greater than 12.6, therefore we reject H naught. Now some of you might ask, what if I have to use the p-value? I like to use the p-value. So I would draw another one. P-value is 0.5. So again, it is the area under here. being equal to 0.05. What you have calculated is 6.62 times 10 to the negative 29, which is a very, very small number. So it's all the way here. Okay? Very small p-value. Calculated. 6.62. So the same idea as here, right? It is outside of the rejection region. So it is less than. So 6.62 times is less than 0.05. Therefore, we have to okay, let me fix what I was saying, because it doesn't make sense to me. So I'm going to erase that. So let me try again with the p-value. So the p-value is very small. So it's a very small area, which is here. Right? It's much smaller than 0.05. And because it is smaller than the significance level, so since 6.62 to the negative 10 times negative 9 is less than 0.05, we therefore have to reject H naught.